Welcome back. Okay, so far we have seen the analysis of BJT amplifiers. Those are common emitter amplifier with without emitter resistor, common collector amplifier and common base amplifiers. Now in this class I would like to introduce the small signal equivalent circuit for the FET or Mosfet and also the graphical analysis for the Mosfet circuit. Let us see the Mosfet inverter diagram to understand the graphical analysis of Mosfet amplifier. So as transistor amplifier or transistor inverter, basically the Mosfet inverter diagram is like this. Okay, this is the Mosfet with the source at the ground, means it is in common source configuration, and the drain terminal is connected to VDD through RT resistor, and at the input, that is at the input means gate, in common source configuration input is at the gate, output from the drain terminal. Okay, at the gate we have both the VDD source and signal source Vi. Okay, so let us see first of all the graphical analysis with reference to this diagram. In case of graphical analysis, what you can study means, okay, on the output characteristics of this CS amplifier, on the output characteristics of CS amplifier, plotting the load line, and locating the operating point, and with at the operating point, let applying a signal at the gate, and the corresponding drain current and the corresponding VDS voltage variations, you can check the graphical analysis. Okay, so the diagram now shows the output characteristics of common source amplifier or common source configuration, the characteristics in between ID versus VDS, and this is the load line from the output loop. You can draw a straight line on the characteristics, that is called the DC load line, and where this DC load line intersects the characteristics is referred as Q point, but for linear amplification it should be middle of the load line. Okay, and now we are going to apply a time varying signal at the input, that is at the gate. With reference to this, the corresponding the time varying drain current flow you can observe, and the time varying voltage drop between drain to source also you can check out. That is the graphical analysis. After that, as usual, like BJT transistor, let us see how to derive the AC equivalent circuit and also the equivalent circuit for the BJT transistor. But before going to see that equivalent model here, with reference to MOSFET, one of the parameter is transconductance GM. It is very important parameter, that is GM. GM is defined as the ratio of output current to input voltage. Here in CS configuration, what is the output current? That is the drain current. Input voltage is VGS voltage. Therefore, GM equal to ID divided by VGS. Where the drain current is given as, already in the subject EDC, you have seen the drain current of MOSFET as 2 times of Kn into VGS minus VT of VGS. Okay, this is the drain current equation. So if I substitute this equation, okay, of course, the equation where Kn is referred as conduction parameter, which is the function of length to width ratio. Its value is given like this. Kn equal to Kn dash divided by 2 into WL into WL. That is Kn dash divided by 2 into WL. That is the Kn is in the Kn is in terms of W by L ratio. Okay. Therefore, GM value is by substituting this instead of ID, it becomes like 2 into Kn of VGS cube minus VTN. So this is the equation for GM. And it is also expressed like this: the GM equal to 2 into square root of Kn into ID cube. You remember both these equations, because sometimes while solving the problem based on the given data, you have to apply either previous one or this formula. Okay. Then coming to AC equivalent circuit of the above circuit. In the AC equivalent circuit case, all the DC sources must be 0 and they should be in the short circuited form. That's why the input the DC source is shorted. Similarly, the VDD is connected to ground. That's why the RD resistor comes in parallel with the drain to source of this transistor. Okay, this is the AC equivalent circuit. Now, the small signal equivalent circuit of Mosfet is this is the diagram equivalent circuit. If you observe here, the gate to source is open. Why? Because the MOSFET offers very, very, very high input impedance, and by the name, the gate is separated from the transistor by an insulating media. Okay, so that it offers very high input resistance. That's why it is represented open circuited in the equivalent circuit. Whereas in the from drain to source, it is represented with the current source with the value GM VGS. Like a transistor, it is same. Okay, so this is the small signal model for the MOS transistor. Suppose if you consider the channel length modulation, like base width modulation in case of BJT, the R0 resistor comes in parallel with the current source. Okay, where R0 is given as inverse of lambda into IDQ. Okay, where lambda is the channel length modulation. Okay, so these two types of equivalent circuits without channel length modulation and with channel length modulation. But those are the equivalent circuit for NPN transistor. Now this is the equivalent circuit for PNP transistor. Only the difference is the polarities are opposite and the current direction is reverse. The current direction is in opposite direction. Okay. And in the next class, we can see the analysis of MOS amplifiers. MOS means MOSFET amplifiers. In the MOSFET amplifier case, common source amplifier, common gate amplifier, common drain amplifier comes. Okay. So in next class, let us see analysis of common source amplifier first of all. Okay. Thank you.